In this video, we're going to go do some hydrate analysis problems, so lab style problems. I highly recommend you watch the demonstration on the Hydrate Lab so you get a general sense of what it looks like. It's basically this picture here where you see we heat up a hydrate. If we first weigh the hydrate, then we heat it up, and then we remove all the water essentially by heating it up, and we reweigh it, and we see how much water was lost in that process, and we can use that with some math skills to figure out how many waters were attached to our hydrate to begin with. And so that's the whole purpose of what we're going to do now. We're going to take a look at that process in more detail. So if we look over here, for example, we have our initial hydrate was blue. We decide to heat it up for 20 minutes and it becomes white, and that's because all the water left. And we compare our initial and final mass, and we get our mass of water that escaped. And so we can use that information to solve problems like this. So there's a few different problems we're going to go over, but essentially these are the main steps. You need to figure out the mass of your water. You need to convert the mass of your water to moles, do a mole ratio, and then afterwards you need to round and determine your formula and then name it afterwards. So let's go ahead and do some sample problems to solve, to learn those steps. And again, we'll start off with examples like this, and then we'll do some more lab-based examples where you might deal with some of the equipment. For each of these slide deck questions, there's answers that can be revealed, and there's also video answers provided if you need them. And then, of course, there's this video where you can check your work as you do the problem. So let's go ahead and try some problems in our handout. So we'll start with this one first. A hydrate of barium hydroxide, and we don't know what the X is, we want to figure that out, has a mass of 50 grams. When heated to drive off water, the residue or the anhydrous substance has a mass of 27.2 grams. Determine the formula of the hydrate. So first, we need to find the mass of the water. And so essentially the hydrate, its initial mass was 50 grams. And after we heated it up, the final mass was 27.2 grams. So we're going to remove that 27.2 grams because the difference between them is what your water was. And so we do 50 minus 27.2, and we get 22.8 grams of water. So we have 22.8 grams of water. And this is because we know the mass, I'm just putting this in brackets here, so, or a little asterisk here. So the mass of the compound is the mass of water plus the mass of your anhydrous, which in this case was the barium hydroxide. So the anhydrous. And so to find the mass of the water, you just do the mass of the compound minus the mass of the anhydrous, so the 27.2 grams there, and you get 22.8 grams of water. Now, we need to convert those grams into moles. So remember that the moles is equal to the mass over the molar mass. So that's going to be 22.8 grams divided by the molar mass of water. So the molar mass of water is 18.02 grams per mole. And that's because this is for water again. Cross out the grams, and you get 22.8 divided by 18.02. And you get 1.265260821 moles of H2O. I'm not going to round just yet because we're not done doing all the work. What we also need is our moles of the anhydrous. So this was moles of water. We also need the moles of the anhydrous because we want to take a ratio between the anhydrous and the water. When I say anhydrous, it just means a substance without the water attached to it. So we have the mass of it over here. Now we need to find the moles of it. So our step 3 is to find the moles of the ionic compound, which is barium hydroxide. And we're going to do that by doing the mass over the molar mass. of barium hydroxide, not water this time. So the barium hydroxide mass was 27.2 grams. And the molar mass, so we have 2 oxygens, so that's 2 times 16, plus 2 hydrogens, 2 times 1.01. How do I know I have 2? Well, if you look at the formula, you have 2 and 2. And then plus the molar mass of barium. Barium is 137.33. So plus 137.33. And I get 171.35 grams per mole. Cancel out the grams and you get moles left. So we have 27.2 divided by that answer. We get 0.158739422 moles of BaOH2. So now what we're going to do is we're going to take a ratio to figure out what the X value is. And when I say a ratio, we're basically doing the divide by small step. If you remember back when we were doing the empirical formulas, we had to divide by small. And so we're doing the same sort of idea here. We're going to do a ratio between the amount of water and the ionic compound. So the X value is going to be equal to the moles of water divided by the moles of the ionic compound. So the moles of water is the biggest mole value, so 1.265260821 moles, divided by the moles of the ionic compound without the water, 0.158739422 moles. Cancel out moles and we get, so 1.265260821 divided by that answer there, and we get 7.970678003, which you could round because you're pretty close to rounding in that rounding range there to approximately 8. So what you just did is you just found the X value that you were looking for over here. That's it. So you basically said there's 8 waters attached to your formula unit. Another way people sometimes write this, just to show you, this is an alternate way. You don't have to do it this way. Some students will do this as their steps. So again, you don't have to write this down if you don't want to, but they'll put 0.158, so on and so forth. I'm not going to write all the digits, but BaOH2, and then they'll put their dot, and they'll put 1.265, for example, H2O, and then they'll divide here. So they'll divide it by 0.158. That gives you the 1. And then this here divided by 0.158. This gives you the 8. And so you have your formula found for you. So that's another way you could have written the workout. That works just fine as well. But our final step is essentially just taking the X value and plugging it into our unknown formula. So we had the BaOH2. So therefore, the hydrate formula is BaOH2 dot. The X is 8H2O. And you can say its name is barium hydroxide, octa for 8, hydrate. And so what we just did there was use some data from a lab to find the formula of a hydrate. We basically took a 50-gram sample of a hydrate, 50.0 grams. We applied some heat and found that at the end, so let's say it was green after we did the heat. It's a white color. At the end, it weighed 27.2 grams. And that's because as you were heating it up, what left was the, well, water. And assuming you heated all the water up, or you evaporated all the water, that's how much water would have left your compound. And so the difference in their mass, the 50 minus 27.2, is how much water left, which worked out to the 22.8 grams. And so using the mass of the water, the mass of the anhydrous, we converted them to moles, did a mole ratio, and found what the X value in moles is for the water. So do not put the mass value here, because this needs to be the mole value with the ratio that you discover. So in this compound, the ratio between the ionic and the water is a 1, even though you don't have to put the 1 here, a 1 to 8 ratio. And you're really always going to get 1 for the ionic and then some other number for the water, because your ionic will always be sort of that smallest that you divide by. And that's why you'll get a 1 there, and then you'll get a number over here that you can generate round, assuming you don't have too much error. So in the next lesson, we'll do another sample problem that's similar to the one we just did, but you can try it yourself first and see if you're on the right track, and then compare with the video lesson that was made. And then in our last video lesson, we're going to do one more sample problem, but a more lab-based sample problem.